Hey everyone, welcome to another Manufacturing Live. Today, I got a treat for you because we're going to be chatting with Don Glaske. Don, buddy, tell us who you are, what you do, and how you ended up sitting in that desk right there.
Well, first of all, I got started way back when I had an interest in engineering and manufacturing and design um, from just being a kid. And I grew up in rural Wisconsin. I still live in Wisconsin, if you can't tell by my accent. Um, and just being living out in the country and working on different farms and working on for different um, employers, everything had some type of um, some type of equipment, some type of farming equipment, some type of things that needed to be, maintained or fixed, or ended up being, they looked at you, to help fix it and those kind of things, and just putzing around with motorcycles and things like that. So I got into design and also manufacturing, where learning how to weld at an early age, and also how to the most exciting part was learning how to use a acetylene torch to cut things off early on. That was fun. So that got me interested in that. And then, of course, throughout into high school, I took many of shop classes and a foundry class. We had a really good industrial arts program where I was at, and all kinds of different things we did, from wood to metal to, like I said, like foundries, all that kind of stuff. I really got interested in that. And I took that on into school and got an engineering degree, and then started out in engineering, and then worked my way more into both sides of the coin, you could say, engineering and manufacturing, where sitting on meetings where we were releasing prints for manufacturing, and we were going through them, whether or not they'd be manufactured in house or if we would do them at our facility, benefits versus the cons, and why we would do that. And then also from there, got me into working for computer technology, which we are now GoEngineer. And I worked on the manufacturing side of CAM and things like that on for SOLIDWORKS CAM and CAMWorks. Now I'm the team lead for DELMIA. So DELMIA manufacturing. So that's kind of open-ended, right? That's could be a robot programmer, that could be NC machining, that could be factory flow, different things that we can talk about. But that's how I kind of got here, and it's been a fun ride so far.
Yeah, so I want to pack a couple things in there because you gave a really interesting journey to get to the point where you're at today. I have some questions about that because you and I are both farm kids, grew up in a rural area.
Mm-hmm.
Little different accent from Nebraska to Wisconsin, but the same experiences, right?
Yep.
The one thing that we do want to remind everyone, and I forget this, I always forget at the beginning, is this is a live show. If you have questions, you want to ask Don, unique questions, feel free to put them in the chat. Go put them over there. We'll read them as we go through it. But you talked about your early age, and your early age of getting your hands on really sort of formed what it was, similar to myself, right? Because you actually get to be around and work with those things. Like, talk a little bit about how that formed your interest in how mechanisms work. Just what was it that sort of sparked that idea, right? If there's some young kid out there or parents raising kids, what was it that tripped that trigger for you to get into the engineering manufacturing side?
I would. This will be I'm guessing this might be the most unique statement you've ever heard. Is I like destruction. I like taking things apart and trying to put it back together. I wouldn't break it. That was not my intention, was to break it, but to take it apart and see how it works, right? I did really good at the mechanical stuff. I failed horribly at anything like electrical. So that could have been taken apart. I'll date myself. I was taking apart the old handheld football games, where there's those little lights lit up, right? How does this thing really work? Take it apart. It's just pretty much a circuit board and some wires. Well, I don't know what that is, So, but getting into the other things of levers and things like that, where a lot of times I was tasked, depending on where I was working for which company when I was a kid, of course, you kind of know this when you're about 8 miles away from anything that's like retail or open. There's a lot of things and I was youngest I was by 5 years the youngest kid in the family. So I was kind of growing up on my own a little out in the country. I was just delegated not to do about 3 certain things. And that meant driving the car on the road and a couple of others. And other than that, I was free to go. So there was a lot of stuff for me to get into. And that's how I started out working early, is for things to do other than baseball and doing things that a normal kid would do. But I remember learning how to weld very young and being told not to weld inside the baler because there's hay in there. And I remember lighting my shirt on fire and learning real quick that was a good suggestion when it was told to me. It's getting kind of hot in there and a little smoky. And I'm like, that's because my bottom of my shirt's on fire. So got out of there real quick. But yeah, so it went from also, like fixing guards and fixing things that weren't working. No one was around. My employer or whoever was where I was working with, it was pretty much taken to the shop, which was a pull shed, right, with a bunch of tools everywhere. Yep. And there's a vise, there's this, there's that, fix that. So or you get a new equipment and they're like, these guards are horrible. You can't do anything with them, right? So you tweak them, right? And of course you would wait till the warranty was over, but I don't ever remember working for a place that ever bought anything really brand new that I had access to. So, it was always used stuff anyways, but that was just tweaking things like, why does that flap? That's horrible. That's just like maybe even making it safer, where I remember there were some guards where there was nothing to stop them from coming down. And if you had your your fingers in the way, it wouldn't take your fingertips off, but it would really hurt, or you could lose a nail because it would bang so hard. So just making safety things where I put in just a safety latch or a stop to say, if this comes down, it's not going to come all the way down until I move it. Those kind of things. And I got asked, like, who did this? And until there was a complaint right away, until they like, oh, that's a good idea. Those kind of things. So that's where it kind of started. I like to take things apart. And then I think initially I was just taking things apart, and then my father told me that I had to put them back together. So if you're going to take anything apart, you got to put it back together. So then I learned from that, and then these days you can take pictures of what something's supposed to look like before you take it apart. Back then I didn't really have access to, the Polaroid camera. I'll date myself again. The Polaroid camera I had access to, but that was very expensive to use, I was told. So don't take random pictures of stuff you're taking apart. So, but then that got me into also doing diagrams and writing things down, and got me into that mode. And hey, why does that look like that? Maybe we should move that there. They got me into the design aspect of it too. And then also, now that I have the design, how do I make it? How do I do that? Early on, learning how to even do form things in the forming machine, or in a vise. I'm going to bend that material in that vise or pound it, whatever I'm doing.
So you're mentioning welding. Did you start stick or MIG?
Of course I started stick, because
I
was not trusted with any wire feed. I was not trusted with, I was given stick for sure.
So you started old school and the best way, and then moved towards the more automated way, right?
Yeah. Which I had a hard time adjusting to the wire feed and all that, because I was like, well, I'm just supposed to.
You actually have to reach the gun in there versus just having a big long stick where all you gotta do is
right.
Yeah. So the baler story, round baler, square baler.
This was a square. Yeah, this is a small square.
I
guess we had a lot of small squares. The big ones weren't really into it yet, and there were some rounds, but it was a lot was a lot of small. Okay. A lot of small. Yeah. So to this day, when I get from baling hay and stuff, being in, I get anything on my back or grass from mowing lawn, I hate it. Man, do I hate it, just because of the hay. Yeah, I don't like it.
So did you grow up doing like hired hand farm work then, like throwing bales and all that stuff too?
Yeah, so we do that, and then by us too, I also worked for a couple of years at a Christmas tree farm. So doing that, and then, which is a whole different aspect of all the different equipment you get them use and things, from spraying. Yes, they paint the trees at the end before they ship them. I'll give that out right now. They're green, right? So not all get painted, but some get painted, right? So so just dealing with all those kind of aspects, but also too, when I started doing the fixing things, I guess when I had to fix things, it started because I had to do it when I was working, because no one else, I was out in the middle of nowhere. They dropped me off. I was 13. I didn't have a license yet. Doesn't mean you didn't drive on the road with the tractors and things like that, but here I'm out in the middle of nowhere, and I can't do anything. So it just gets you to, I got to fix it. And there were no phones. Our boss had one of those big ones in his truck, right? But I think it was like $5 a call.
Back when they used to charge for talking, where now it's just free. And they charge for data.
Right.
Yeah.
So we can use
the Motorola big bag phone, the Motorola ones with the little antenna that went out the back window.
Oh yeah. You could also you could put straps on it and wear it like a backpack. That's how big it was. It was huge.
Yeah. So you mentioned you did industrial arts in high school, and then you went down a path of engineering. Let's talk about how did you go from working with your hands, building components, taking it apart, doing really cool stuff in high school and industrial arts, to decide to go to engineering? Like, what was that process like? Because it sounds like you're very mechanically inclined, and most people would be like, oh, you should go into being a mechanic or XYZ or that kind of stuff. What drove you the creative way of engineering?
I'll be blunt, is I saw a lot of other people's designs, and I'm like, man, this is just like anybody else. Like, this is horrible. I can do better than this. Those kind of things. Or I think I wanted to get into the aspect of design because I like the design and I like the end product, right? So I thought it would be fun. And the only way at that time to really get, other than working your way up, is you had to go and get a degree in it. So I looked at it that way, where I can always be back. I always figured I'd be somewhere on the manufacturing side of things somehow. If that comes to, writing standards for the companies I work for design and manufacturing. So in manufacturing and design are using the same thing. Are you thinking on the same page to be efficient? Those kind of things, where if just as simple as, if we don't bin stock that fastener, it's not in our toolbox inside SOLIDWORKS. You have to use what we have, unless we need to order it for whatever specific reason, then we will. But those kind of things. And it got me into thinking, I think it got me on the other side of things, on the other side of the wall, to think that way versus when you got it out to the shop. And it made me respect both sides for sure. Obviously, that, it's the old age battle of those guys aren't so smart and those guys don't know what they're doing, those kind of things. And liaison in between there to understand where both were coming from and try to figure out how we can all maybe have a beer at the end of the day and like each other, those kind of things, and understand where everyone was coming from. And standards really helped for sure. Is, everyone's, you didn't go off the path, right? And that's where a lot of times engineers get in trouble, in my opinion, is they go rogue and they take it out, and the guys out in the shop have never seen it before, don't know how they're going to make it. And then second of all, how are they going to get what they, a lot of times I've seen where guys come in, the newer guys, or guys would throw stuff on their desk and say, how am I going to get my hand in there to weld that? And someone sits there and the younger guy goes, come on, let's take a walk. And you show them and, yeah.
Well, it gets worse now when you start talking robotic welding, right? Because now the gun and the robot have to reach in there. You can't just expect some welder to lay on his back and get showered with sparks, right? Like, it's a little bit different world than it was even back then. So what was your first job after college? I assume you went for mechanical engineering, or what type of engineering did you go for?
Correct. Yeah. Yes. Like mechanical with, essentially it was mechanical. We could have went, like, it was for mechanical, like, what I want to say, mechanical influence, or there was like at that time we also had one for environmental, so you could do hydrology like that. So I chose the mechanical side, of course, But
Okay.
my first job out of college was for a company that made agriculture attachments. So I was
Okay.
doing exactly what I was doing at 22, 23. That's what I was doing when I was 15, 14 is, designing brackets and designing mounts and trying to come up with something that we can mass produce. So I went through the process early on of, okay, we got that. Now we're going to get these stamped because we got to make 500 of them, right?
Right.
Or does it make more sense? Or does it make more sense to cut them out of a plasma cutter? All that. I went through that whole scenario, which is very fortunate because I went on right out of college. I went through that scenario where I had the freedom, with supervision, of course, but freedom of understanding and exploring different manufacturing processes early on. And where this company is near the Twin Cities, and by Minneapolis, St. Paul, Minnesota. So there was and again, my manufacturing was unlimited. I had all kinds of different avenues to go down and how we were going to do it, different things like that. And we ended up going with, based on the thickness, we first started out with plasma, and then we got the design down to where we ended up cutting it with a laser because the material was thin enough to do it that way.
Okay. So I have a question about that. But first, if anyone has any questions for Don about manufacturing and his journey, please jump in the chat, ask some questions. Again, this is live. But you mentioned something there, Don, that was a little unique is, as farm kids, you grow up building things out of necessity, right? And so you may use a torch, you may use a stick welder, you may use those components. And it's generally the design is functional, but it's based off the material you have, right? And my experience was similar to yours is like all of a sudden you go to a company and it's like, how do you want to make it? And instead of making one, we're going to make 500 of them, right? And here's all the cool tools that you've never had access to before, right? So as you go through that engineering process for manufacturing, how do you think about it when you do that? Because there's engineering, which is I can make whatever widget I want, however I want, and we'll figure out how to manufacture it later. And then there's actually engineering for the process that I want to make it on. How does your mind work when you do engineering for the manufacturing process first?
Sure. That's to lead off on that, from where you left off is just that. I would think how, based on how I would design this or what the piece, kind of the vision of whatever I was going to design, how would this get manufactured? That's the first thing I thought of, on that. And I think some of that on the, some of the newer people, meaning the newer, more greener designers, they don't think that because maybe they didn't have that background, right? So I think that, all that other stuff prior to when I first got in there was, I would think, how are we going to make this? Are we going to mill this? Is this going to be, how many are the, what is the process going to be? And how are we going to, do we need all these fillets, all these radiuses, or can we just have one radius that someone just has to cut with one tool? And those kind of things where it looks prettier if it has these four different radiuses or different diameters on certain things. But really, do we need that? Is it easier, especially if it's a punch or it's something you're going to get a die for? Why not make all the holes the same if they don't have to be a certain size? Those kind of things. Right. And also, too, got me. We were talking earlier about the electrical side of things, why I wasn't a big fan. But of course, in agriculture equipment, there's always electrical involved, right? So I got to learn that too early on of just like remembering, like wiring things up just with a ton of, butt connectors and heat wrap stuff. And then when we got it all done and it worked or whatever it was, and then like you would hand it over to someone and say, hey, make a circuit board for this. It was amazing. They come back and I'm like, all those wires we had in, it's just this little board about EO big, It was amazing. So I got to see that process too. But to get back to your question is that essentially I would just think, how would this get made? And it really is what I knew at the time, what my brain had access to of how things are manufactured. And early on, when I got exposed early, right out of school, what was nice is I didn't have to interview out of college. I actually had a job before. So I never even made a resume until later on I wanted to get a different job. So I never had to go to the resume writing classes or anything because I already had a job. So I was very fortunate that way. But when I got exposed to all the different manufacturing processes, what was nice is I had I understand. I also learned getting quotes back too, and seeing those. That's a big thing too. Of like, oh great, yeah, we can stamp that, but it's going to cost X amount just to do the stamping die. Yeah, maybe we should just burn a bunch of them out. So and deburr them and do all that other, just all that stuff got into where you were. And then also tweaking the design. We didn't have other calculations and things like that. And then just good old beating the product up, right? Out in the driving something too fast that, you're not supposed to go, just see what fails. I know many of that was like, oh, that bracket broke. What break? The bracket or the weld, those kind of things, based on that, what kind of material do we use? Here it ended up being where we were thinking all this different stuff, and all of a sudden it was just easier just to make it out of L-shaped brackets and just weld it and cut it as a cope and weld it together and be done with it instead of all this plate. And it looked prettier, kind of, not really, but it's just more for things to rust anyways and more expensive.
Yeah, it's always been interesting to me because my first job was field test engineer. So my job was to help build the prototypes and then go break them. Right.
Mm-hmm.
And so you have a whole different respect when you start throwing stress and strain gauges on stuff to see where it's going to break and how it's going to break, especially after like the group I was in, we made our own prototypes. Right. So we made all the equipment or made all the components by hand, put it all together, and then went out and broke it. Right. And I think sometimes the nice way to say it is we get too cute in engineering sometimes, and we want to do all this cool stuff when the simplest answer for form, fit, and function is make it a simple bracket, make it all the same fastener size, make it all the same holes, all the same relief, because then my 3/8 bolt takes a 406 hole and everything is that way. And if I have to take it apart or the person servicing it has to take it apart, they can do it with 2 or 3 different wrenches, right? Like, I build old cars and hot rods. I can take an entire 60s Chevy vehicle apart with a 9/16, a half inch, and a 5/8 darn near, because all the hardware is the same, right? And the advantage you get when you do those types of things is if I buy 5,000 half-inch bolts, it's cheaper than buying 100 half-inch, 100 7/16, and 100 3/8. Because I can do batch quantity on ordering. So if I design for those standard components, not only is serviceability easier, but the manufacturing process is easier too, because then every print has a 406 hole for a 3/8 bolt, and everybody in manufacturing knows we have a 406 hole.
Right.
I mean, it sounds like you sort of described that a little bit, Don. Is that sort of how you looked at stuff when you guys were doing attachments as well?
Exactly. Yeah. We would always like, okay, it's hard to, well, back then it was a little different because the metric wasn't so prevalent, but now it's so prevalent now. But even like you're saying with the hot rods, you could drop a bolt and you find it on the bottom of the shop floor, right? Now, if you drop a bolt inside of a car, good luck finding it. So all that space issues, all that worked and even now I still am a nerd with agriculture equipment. I look at it. I'm around it all the time because where I live now we're 5 miles out of the city. So we live out in a rural area, more traffic than you would think. But I see these different things, and I actually see the sprayer that I first worked on for a company over in the east side of Wisconsin when I first moved over. Now I live in the Appleton, Wisconsin area. I still see sprayer. Just last week it was spraying across the road. That was the spray, one of the sprayers that I worked on, designing the tanks and tank mounts and all that kind of stuff. So it's made its evolution in 20 some years from there. But I remember taking it out, like you said, taking it out on the trial track we had, and seeing if the boom would break and all this other stuff. Right, that's how I first got introduced to 3D wireframe, was working on that boom. And when I remember being a 3D wireframe in a CAD, where I'm like, there's got to be a better way to do this, and then shortly after I got introduced into SOLIDWORKS. So all that kind of stuff. But I wish we had that, because then we could have done different things, but I still remember figuring out bend allowances on paper and doing all those kind of things where a lot of times those are all kind of automated a little bit more. But what's interesting is, like you were saying earlier about how the try to be you said the word cheaper, right? One of my old bosses would freak out with that name. He's like, we don't make anything cheap, we make it inexpensive, and that means it's efficient.
Yep. Yeah, I mean, you can play the words however, and that's the end goal, right? Is we want to make it efficient. And especially when you're talking, the fields that you and I sort of come from, is serviceability is huge.
Yeah.
Because if a bolt shears off in the middle of a field, I can't have a unique specialized bolt that goes back in that hole, because farmers won't deal with that. They will shove whatever bolt they have back in that hole. So if we make them all the same, or as close to same as possible, then we're holding up the integrity of the design that we built, right? And you mentioned the ag equipment. It's funny, over Memorial Weekend, I put a pay at my place, and the Heston baler I have was available when I worked at Heston. I picked up a Vermeer rake last weekend from a buddy. So it's funny how we always go back to our roots when we do those types of things. Yeah. But you mentioned getting into SolidWorks. So let's talk a little bit about, how long have you been using SolidWorks, number one? And number two, what was it like when you started using it?
Yeah. Well, I started out, I won't date myself, but I started out using, they were still transitioning from a drafting board to 2D. And everyone knows what the popular 2D is at that point. And
draft site.
Yep, exactly. Actually, it was DWG Editor, they called it.
Yeah, yes, I remember DWG Editor. Yeah.
But before that, we were doing wireframe stuff, and only thing is, the software for us at that time to do any type of simulation was so expensive, and we couldn't do it. The smaller company that we were, it's just that wasn't feasible, right? And then we got a little bit more into it, and like, what is this? This is SolidWorks. What is that? What's new? And it has developed quite a while, from when we first came out, and then all the stuff that got added to it. One huge benefit I always thought is each time they added different, what we would call add-ins, right? We would call sheet metal, we would call simulation, or even just the surfacing. The price never went up. It's like, oh, they're gonna have surfacing. I wonder what that's gonna cost. And they never charged for it. Well, I was amazed by that. I'm not gonna toot everyone's horn here, but I was just like, they're adding all this functionality, and it was like, it wasn't they were bolting all this stuff on and making it integrated, and it was like, this is awesome. Where we got into it, but when the biggest thing that we saw when we first got into the 3D side of thing is just everything being linked, where we didn't have to go change a bunch of different views. Everything's parametric. The view would update. Like in the 2D, we would have to go change X amount of views. And of course, someone forgot to change it in the left-hand view, which is probably the most important one, because it's the depth of the block we're mounting on this machine. And hey, it doesn't fit. Imagine that, all those kind of things. So just hearing like editing blocks and groups and all that. So that was a nightmare, just, and then, oh, hey, I did all that except for that one detail view I forgot to update. So the tap is the wrong size. Great. That's great. Yeah. So, and when we did a lot of design for the agricultural stuff, we would always, depending on what machine it was going on, we would actually use the type of fig, if they're metric or whatever that was, we would use, because it was being a transition where there was some, what I would call like a soft metric. There was some anti-inch, and then there's some metric depending on where the engine came from, or the motor mounts, or anything like that. We would try to use the same type of fasteners. If that was ANSI or metric, we would try to something that was common on the tractor or common on the implement. So that, like you said, if you had something break, could you take that one bolt that there's six bolts on there holding something down? Could you take that one bolt off in the middle, to repair the sheared bolt or use it for the sheared bolt that happened, and then still get by and get home or finish what you were doing. Those kind of things we took into mind with that as well. So getting back to the SOLIDWORKS, truly SOLIDWORKS, I think we were 2004. I think that's when it was ish. I think in that range. And then, so it was it was early on, but it had been around for 6 years or so, 8 years, 6, 8 years. And we just saw leaps and bounds on the sheet metal, or not necessarily later on with more sheet metal, but more so just the parametrics with it for sure. Not having to update all these views and, your layout would update because you're updating the part and all that. We just saw so much less rework, less come out to the shop. What were you thinking type things, right?
Yep. So scale the viewport versus scaling the title block around the 1-to-1. Sol prof, sol draw, regen. Yeah, all of those. Wearing out the space bar. Yeah, I was one of those folks with you. And do you know where the first bolt gets pulled from ag equipment? This is my anecdotal answer based off years of dealing with this.
No, tell me.
It's always from the guarding. If you ever break a bolt, the first bolt they'll take off is from the guards.
Yeah, right.
Guaranteed every time. Right?
Exactly right. Yeah, I should have known that. I was thinking this.
Just little things that you think about, but like coming from the background sort of like you have and sort of like I have, where you grew up working around these, servicing these, and then you get into that, I feel you get a unique perspective, right? When it's 103 outside in the middle of the field with no wind and you're sweating and you got to get this fixed, you sort of become resourceful like everybody else. So when it comes time to design it, you have a different look on that. Now, you started out in engineering, went from board to some 2D to SolidWorks. How did you get to the point of then becoming an applications engineer, and where did you start as an applications engineer?
It came from, I think, being in the industry for as long as I was, because I was there 20 some years in the industry, and just working and seeing. I thought I had a lot to benefit. I liked to teach, and I like to have people see the light bulb come on for people. So I trained a lot of our new hires where I was at on certain things and how we do things, what our standards are. It all started with coming up with standards because we never had any at the last company, or one of the last companies I had, and the other ones too. Is let's come up with standards because everyone's just shooting from the hip here. Just kind of like whatever we're doing here, we're doing. It's like, well, that's not efficient at all. That's where we get into the cheap versus efficient and inexpensive, right? So
everybody call it part 1 and just save it in a network file. See what happens. We don't need a standard. You just model however.
Right, exactly. So just so everybody was on the same page, and if there is a problem, there's not all these avenues you have to go down to find where it went wrong. It's keep it simple. Just the KISS scenario again of just keep it simple. And if it needs to be more, I won't say if it needs to be less, how would I say this? If it needs to be cheaper, then we'll go down that route, right? But let's be efficient, which should make it more inexpensive, right? And it should make our designs more solid, meaning everyone's kind of on the same page as best they can be. Of course, you have to think outside the box to be a designer too at times, where how do we get this done, right? So with that being said, I would think me being able to train people, teach people, because I kind of was our first CAD learner, even 2D to 3D. And then, when that took out into the shop, when we got more equipment, lasers and machines and things like that. And then also talking about the AE part, I had kind of a well-rounded background of, for training and talking to customers about I've been where they've been. I understand when things aren't working. I understand you need to get something done. I understand all of that, and you kind of think more like an owner than you do just in general, you want to think that way, where what's the best way to help this person's problem, and the customer's problem.
Well, and one thing we do have to clarify a little bit is cheaper is relative. I could be making $1 million piece of equipment, and cheaper means 900,000 versus $1 million, right?
Right.
And the other thing that comes into play too is I could have a cheaper product because the market segment requires it for a given niche, right? If I'm pulling a 32 row planner, that's heavy duty. But if I'm creating a market for a 4 row planner, I can keep the same concept, but lighten up all the material, and it becomes a cheaper version because I'm only pulling 4 rows, and it's used in South America somewhere in the mountains, right, where you can't get any more. That's a cheaper version, but still providing quality. So cheaper doesn't always mean 10 cents versus $10. It's a varying degree depending upon the equipment and market segment you're in.
Exactly. And that's the full realm of it, is just like you said, the whole aspect of the spectrum of that is you want to try to make products, especially if it's a good design, you want to make it accessible where it applies to everyone. And so everyone can benefit from that. And that's one thing, like you were saying, is where you get into, following standards and things like that, where now if we go to from a 18 row planner or to a 4 row, we apply the same standards, but now we're the material's less thick because we can be, we're making it more efficient and more inexpensive for everyone, make it at a price point that someone could take advantage of the automation part of it, right? Of whatever we're making, for sure.
Yeah. You made me think of, you're talking about the forces and stuff, anecdotal story. Nobody quote my math, so I'm telling it anecdotally from 15 plus years ago. But do you know, like when the train cars, when you hear them do that smash, when they start and stop, on those knuckles that lock together like this, how many pounds of force do you think is there when you hear it go pop?
To open it or to latch it?
No, not to open or latch it. Like when the trains apply the brakes, or when they go to take off and you hear all the slack come out of all the cars.
Oh,
each of those knuckles, how many pounds of force do you think is applied when you hear it pop?
Oh man, it's got to be astronomical. I don't know.
It's over 1 million.
Yeah, I was gonna say it has to be.
So if you ever wondered why those knuckles are so heavy between those train cars, it's for that force that happens when it comes in and out. So here in Omaha is obviously where Union Pacific is at, right? So we used to work with some SOLIDWORKS customers, and they did the analysis on that. They would also do the analysis, like airflow analysis over the train cars. And then they would do, anytime there was a wreck, they would go out and then they would recreate that and simulate it and validate it. So anecdotal story of forces, if you ever hear those cars banging and chugging along, each one of those knuckles, every time you hear that bang, is over 1 million pounds of force on just that knuckle.
Wow.
So side note, doesn't have anything to do with anything other than when you start talking size and scope, it sort of fits in there, right? So when you started the applications engineer, as people who used to have done it in the past, AEs, what did you start teaching? Was it SolidWorks, and what did that look like? How did it fit? What was it like not actually making components every day and getting into, here's the software, I'm now an expert at it?
Yeah, it was an adjustment, right? You like anything else, you go back to when you're doing during the training or whatever, when you're teaching, you go to what you know. So it helped you. That part kind of took you down memory lane of, because you knew when someone asked a question, or you knew where they're coming from, and you could relate to them on your experiences. But yeah, it was different because you weren't really, at the end of the day, you weren't releasing anything for production, and also you weren't out on the floor and seeing anything made, or helping make anything that's out on the floor. Other than the things that you see the customers, maybe they ask specific questions about a part they're having, or assembly, or whatever they're doing, or whatever they're trying to program, or whatever. You could see that stuff, so you get the glimpse of that. But what's interesting is the fields that I've been in, or the manufacturing areas that I've been in. When you become an application engineer, you meet all these different people and all these different customers, and your eyes open to the realm of all that is made essentially, which is very eye-opening, meaning, oh yeah, that's how you, oh, okay. Yeah. Because someone's got to do that. I never thought of that, so that's the interesting part of it too, is how other people do things and how other things are essentially are made. Like if I was much younger and they had how things are made and those kind of things that are on, I forget if it's on Discovery or whatever, that on those type of shows, I watch them all the time. Even though I know how a plastic bottle is made, a soda bottle, I love watching it because I love the manufacturing part of it. I love to see things move in the process of it, right? So, and how that's, so I think you get, as an application, you get introduced to all these different products that people make that you never really thought about before, right? So just like, oh yeah, that would, okay, yeah, you would make, because you just like, oh hey, you would build a die for that because you're going to make X amount of those, where you may not necessarily just realize, is that the right process? But I'm sure they've went through everything. Like maybe it'd be better to do it this way. But when you get into the quantities they're making, yeah, that makes sense, right? So that's the best way for them to be efficient. So I think that's a lot of it, and just to see, and just to relate to them too, of like, this isn't working. How do I get this fixed? Those kind of things. Because I've been there too, where it's Friday and this has got to get done or whatever. I remember plenty of times where I heard some, we'll protect the names. We won't name any names here, but, like, oh, we'll do that next week. Well, there is Saturday and Sunday, right? I've heard that before. So, so those kind of things, but, being on both sides and being in the shoes that they're in, as far as customers, I have a very good perspective of what they're trying to do and the pressure they're on.
Coming from there, you have a lot of empathy, right? And what it takes, because you've been the person that's pulled the all-nighters and actually, shipped those trucks and done all that work. You mentioned how unique things are made. Another anecdotal story. Do you know the rumble strips on the highway? Do you know how those rumble bumps are made? The ones that are divots in the asphalt?
It's got to be from like a wheel or something, eh?
It is a company in Iowa that makes those machines that put those in. And it is a huge gear reduction box that goes on the side of this machine and puts a tremendous amount of force onto the paved surface and actually indents that. Those aren't cut in there. Those are indented into the highway. And it's this monster box, which is one of the coolest things, because I never really thought about it until you're on site at a customer and they start being like, oh yeah, it's just a gearbox with gear reduction, and the force causes that indentation. It's like, wow, that is one heck of an engineering problem to solve that turns out into a machine that just goes up and down the highways and putting rumble strips in. So
it works off of destruction, right? Because
100%. I get to destroy a perfectly good highway to put a rumble strip in.
Right. Yeah. Like around here, they do them in Wisconsin. Sometimes you'll see them in the center, and sometimes you see them on the side, on the shoulder, whatever. But yeah, here's a perfectly good road. And I think they probably have to do that after hours, after the people that actually laid the blacktop and laid the concrete probably have to do that so they're not around, so they don't get mad. Like, what are you doing?
I just spent months paving this highway, and you're going to roll down it and put divots in it. Yeah.
You put all these holes in it.
Yeah. It was one thing that was pointed out to me is a while ago is people that sort of have ridden that line between engineering and manufacturing and spent a lot of time in manufacturing those deadlines. They generally view the world a little bit different, because you don't get too high, you don't get too low in engineering processes, do or die, because there's always an emergency and there's always a delay and there's always a problem that comes up. And so multitasking and being able to handle those stress points, I think, gives you a different view. And I think, from like an AE perspective, your constant discussions are, this doesn't work, that doesn't fit, how do I do this, I don't understand that, is very similar to like a manufacturing process. What do you think about that analogy, Don? Because someone told that to me once, is like, yeah, you're pretty good at multitasking because it just doesn't stress you out.
Yeah, right. I would agree, because you're doing multiple different things, talking to different departments, and all those kind of things, let alone talking to the customer as well and making sure things are on track. So yeah, I would say, yeah, it makes to this day where, I coach a baseball team. I'm on the board of an athletic department, and I'm an umpire as well, and an umpire director coordinator for the league. And also I do all this other work. And yeah, so you just find yourself doing, because you kind of learn it, and you're kind of, if it's not crazy, it's almost, you feel like you're not doing something right. Almost like where you're kind of like, what's, how come I'm not getting yelled at for something, or, those kind of things. And I'm not saying everyone yells at each other, but it just usually when the people, like you were saying, the stress thing, people handle stress a lot differently than others, right? So I learned, this is anecdotal. I'll give you something anecdotal. I learned something from one of the guys that I work with. He was military, and he, great guy. And I said, are you okay? And he's like, I'm not getting shot at. And I'm like, that's a good point. That's a good point. Because he's like, he used to jump out of planes, and then on when the equipment would land, they would unpin the stuff and then drive it to a location, and then they would get taken out. But he's I'm like, what's a good way to look at it?
That's whole different level of stress, right? Like, this one, we forgot the TPS report. A little bit less stressful job than some of the others, right? So
yeah, for sure.
Yeah. So in this whole deal, we sort of talked about engineering, and now you're back, and I'll say on my side, the good side, into the manufacturing realm, right? You're working on DELMIA with the team that I work on with, right? And we have robotics and factory flow, plant layout, M-bombs, all of these details. You sort of came full circle back into manufacturing.
Correct.
Is it cool to be back on the cool side?
Yeah, it's just the endless, I would say the endless abilities to be able to do different things and have it all put together and have it linked together, and for a common goal at the end, where things aren't all over the place. And I got to bring this in. And I think being in the manufacturing part of it, because that's where it needs to happen. We can do all the other stuff, but if we can't make it, or we don't get good data, or we don't get what we need, it's all for nothing in the end, meaning everything goes haywire. So I think it's nice to have on the manufacturing side, where you see all the designs in the world, right? But now you actually get to help make them. And that's where the rubber hits the road, right? Is we got to make this now, that looks really great, but we're going to make that, so.
Well, and it's, the world's a lot different than when you and I started with boards, right? Now we're talking programming robots and PLCs and conveyors and execution systems connecting to data, and like all these manufacturing companies are becoming data companies, right? And you can hear that. There's lots of people that talk about that and mention it. But at the end of the day, like if you think about the communication and the process, an unpopular opinion, I will phrase this up front, but the reason CAD exists, 2D, 3D board drafting, is to communicate an idea or a thought to manufacturing to get built. Right. If we weren't building in manufacturing, you wouldn't have a need for those tools.
Nope.
That's just sort of how it works, right? So in manufacturing, yes, a lot of times we're the end of the whip, if you will, because it gets designed and built, and then we have to build it under a certain time constraint, which is usually crunched. But the whole idea of CAD is to communicate effectively with manufacturing to build a product in the real world, whether it's 3D printing or subtractive or robots or however you want to do it, paper mache, doesn't matter. You go buy an origami book, it's a detailed set of instructions to make a product. Same thing goes for us. So we're getting closer to the end of the hour. You're a bike guy, if I remember right. Right, Don?
Yeah, I am. Yep. Yeah. I started out on mini bikes and all that, but because where I grew up, there wasn't enough room for 4-wheelers or back in the day for 3-wheelers, right? There wasn't any room. So I ended up becoming a dirt bike kid early on, and that just worked onto the road. And now I'm an old guy with older guy. I should say that. I always yell at my kids for calling me old, but older guy. Now I finally have a radio on it with some bags to put stuff in. For years, was against that. So yeah, I've always been a bike guy, and I started with, I remember buying. That was why I worked back in the day, was for other things, but also just to buy dirt bikes. Break them and buy another one or fix it. Or usually I was fixing them, but yeah, I was. So if anybody wonders, dirt bike, yes, Husqvarna. I'm a Husqvarna guy.
That's what I was just going to ask, is which brand, because everybody's a brand when you start messing with them.
For dirt bikes, Husqvarna for sure. Yep.
Okay. What's your road bike?
Honda. Yeah, Honda and some other ones. I actually have a retro, they call them these days, right? I have a retro CR 200. That's a dirt bike which it's a 2-stroke, so it means what it means when you turn it on. There's no fooling around with full stroke or all that. It's right out of the gate. You're lit on fire. That thing's ready to go. So for sure. But and on the road side, I'm a Harley guy, of course. But I've gotten buddies now that are getting into the Indians, and what's interesting is all the stuff that Harley makes you pay for. It's on the Indian by standard, so that's kind of interesting. And I know John Milbury is an Indian guy now too, so he was telling me all this stuff is on his. I'm like, that's not even available. It's not even available yet for anything on Harley, but then also too, it costs a lot of money to do that.
Yeah. So. Yeah, no, I'm with you on that. And the reason I asked was actually because, do you know that coming up on June 19th through the 23rd, Iron Swug is going to be riding to a bunch of different user group meetings, and it ends up in Waltham? Like, you can go on this multi-day tour of visiting user groups, talking SolidWorks, and riding bikes. Yeah, and it's going to be on ironslug.com if you want to learn more about it. But that is a cool thing. If you are a bike person and you want to go do something cool with the community, that is a pretty awesome place to start. And they're pretty cool people too. I mean, that's always part of the fun, right? Isn't that the point of bikes and riding, is the camaraderie?
For sure.
So being a car guy, I can understand that, right? You go on car shows and go do all those things. A little bit different. Don't quite get the wind in my hair these days with it being short, but we can all dream of when we were young. So with that, Don, we're at the end of our time. I can't thank you enough, man. How can someone get a hold of you if they want to know more, or they have questions, or they want to learn how all the cool things that you talked about today?
Yeah, they can reach out to, I'm on LinkedIn under, if you search Don right there. If you search me there, you can get to me. And then also feel free to send out an email. You can send it to GoEngineer as well. It's D and then my last name, GLASKE at GoEngineer.com. If you guys got anything you want to run by me there too, if you want to get hold of LinkedIn too, that's fine. And
it looks like it just showed up in the chat. So with that, man, I need to probably let you go because you have a bunch of people to help, and we took a lot of your hour today, but I can't wait to have you back on in future episodes, and we can talk a little bit more about specific processes like machining or robot programming or something like that.
Gotcha. Yep, for sure. I'm on my way to help someone, robot programmer, after we get off here a little bit. So
awesome. Thank you everyone for joining, and we will see you next month. Have a great day.